Alright, hello everyone. You guys are doing good. Remember, drop a like, comment below. Help me increase my retirement account here at Andover High School. So, today what we're going to look at is we're going to look at some pH calculations. How do you calculate pH? Or some different ways to calculate pH, and then look at an example. Okay, so we just can remember that pH is equal to the negative log of the concentration of H+. Okay? Or sometimes it's also written pH is equal to negative log of the concentration of hydronium H3O+. And we have to remember, as we're getting into this, that H+ is equal to H3O+. Okay, that hydrogen ion concentration is equal to hydronium ion concentration. Because in water, if we remember, water is a polar molecule. So if we look at the Lewis dot structure, polars tell me I have a negative end over here and I've got a positive ends over here, slight different in charges. Well, these negative end of water with these unpaired or unshared pair of electrons attract hydrogen ions. So if I have a hydrogen ion solution, well, we know that positives are attracted to negatives, so this is going to attract over to here, and what actually happens is you get the hydronium ion. Plus. So those are interchangeable, okay? So if something that says the hydrogen ion concentration is also talking about the hydronium ion concentration. They are the same thing, okay? So pH is equal to the negative log of H+. So it's really quite simple. So say you have a strong acid, okay, so something like hydrochloric acid. Say if I have 1 molar, HCl, okay, what is the pH? Well, so what we can do here is we know it's a strong acid, so hydrochloric acid is a strong acid, meaning it completely dissociates. Okay, all 0.1 molar of this goes over here. So right away I have the H+ ion concentration. So I can go ahead and plug that back into my pH equation. So pH is equal to the negative log. In this case, what's my hydronium or hydrogen ion concentration? 1 molar. So this would have a pH of 0. Okay, pretty strong acid there. And if we remember on the pH scale, and this is at 25 degrees Celsius, okay? Anything with a pH less than 7 is an acid. Anything with a pH greater than 7 is a base. And if the pH is equal to 7, it is neutral. All right. Okay, now, something important here. I said it's at 25 degrees Celsius, so we've got a temperature associated with this stuff. And why is that the case? Well, another thing about pHs and stuff like that is if I gave you the concentration, let's say I had a 1 molar sodium hydroxide ion or sodium hydroxide solution. Right, well, sodium hydroxide breaks down into Na plus OH minus. We get 1 molar of this as a strong base, so it completely dissociates. Okay, so I've got this OH minus ion concentration. Well, from this, I can actually calculate the pH. Right, asking, well, how can you do that? pH is the negative log of the hydrogen or hydronium ion concentration. How can this affect the pH? Well, water is special in that it's amphoteric, or it reacts with itself, okay, or self-ionizes. Also acts as an acid or a base. So in this case, what happens when water is in solution, or water is with itself, it undergoes this reaction at equilibrium. So this would be liquid, this is aqueous, okay? Or what we see is water breaks down to H3O and OH minus ion concentration. So if I wanted to write a K for this, I would know the concentration, the K is equal to H3O plus times OH minus. Okay, and this is a very special K. This is called the KW. Okay, for equilibrium constant for water. Well, what do we learn about Ks? Well, Ks are set at a certain temperature. So Kw is equal to 1.0 times 10 to the negative 14th, and this is at 25 degrees Celsius. Okay, so going back to our pH scale, why is this set at 25 degrees Celsius? Well, what is our pH scale measuring? Our pH scale is measuring the concentration of the H+. So if we're measuring the concentration of H+, and it sets up at equilibrium, the concentrations of H pluses are going to change at different temperatures. Okay, we know that because K's change based on temperature, right? So the other thing this allows us to see, well, what happens if I increase the concentration of this? Well, what do we know? This system's going to do what? It's going to shift back that way, or it's going to decrease the concentration of this. Or from this mathematical equation, we know the concentrations of these two things are tied together. So if I know my OH ion concentration, I can plug in and solve for my H3O ion concentration. So Kw is equal to the concentration of H3O plus, and in this case we said our OH ion concentration was 1 molar times 0.1 molar. This is equal to 1.0 times 10 to the negative 14th. So in this case, my H3O ion concentration is equal to 1.0 times 10 to the negative 14th. And we can go ahead and put that into our equation. pH is equal to negative log 0.0 times 10 to the negative 14th. And what we come out with is the pH would equal 14. Okay, so anytime I have an OH or an H3O ion concentration, I can solve for the other one or determine the pH. And this is also why bases affect the pH. You know, because this base up here is not putting up H3O or H plus ions. So how does this OH ion affect my H3O ion concentration? Well, it affects it based on this equilibrium that sets up this expression here, this equilibrium expression for water. Okay? And we know these are inversely related. As I increase this one would have to decrease to keep getting that constant number and vice versa. All right? So there was a real quick review on calculating pHs, right, for strong acids and strong bases, right? Make sure we understand this here, these two, this little concept here, and this is on your formula sheet. So this is on your AP formula sheet. Okay, I think they give you both of these if I'm not mistaken. All right. So what I'll give you today is just a couple practice problems as well, just to get used with converting between OH and H3O plus. So, and calculating the pH from that. All right, hope you guys have a great day.